Hi guys, our topic for today is the first battery. In particular, the first battery is the Voltaic Pile, and then we're going to branch out and talk about, what do batteries provide for electronics? It's the electrical pressure that we call voltage. All right, so let's just get to it. We have our Voltaic Pile was made in 1799. This was the first battery. It consisted of two metal plates that were of different material. So copper and zinc were the original materials used. And then in between those two metal plates, we had a conducting liquid. We had salt water to start with. All right. And so since then, batteries have changed a little bit, but the basic battery, even today, consists of, one metal plate, two metal plates, and what we'd say in the center, an electrolyte or battery acid. All right. And if you were to take a large battery apart, you could see that you'd have these distinct pieces that you could identify. All right. And so if we reach back a little bit more into the history, we say that Alexander Volta, he was the scientist who came up with this. He was inspired by the work that another scientist, Galvani, had done determining something he called animal electricity. Galvani had connected, again, two pieces of metal of different types to a frog leg and saw that there was some electricity being conducted that caused the frog leg to twitch. And he called this animal electricity. And so Alexander Volta took this idea of, again, two different pieces of metal, two different types, and he combined that with a substance in between them, just like Galvani had a substance in between that was the fluid in the frog. And Alexander Volta, took it and made his design a little bit more similar to a previous device, which occurred in 1745, the capacitor, which was the original way of storing a charge. All right, and so the original battery and the batteries today are all about providing voltage, which we can see that the name voltage comes from Alexander Volta. All right, and voltage is electrical pressure. Okay, and so those of us who are in person, or those of us who are in person tomorrow, what we're going to be doing is recreating this battery, but very similar to the capacitor, all it's really doing is creating a plate of a lack of electrons, that's our positive plate, and a plate of high concentration of electrons. And when we touch those two together, electrons move from high concentration to low concentration. But this difference, the electrical difference between a high concentration plate and a low concentration plate, that's our electrical pressure we call voltage. All right, so step up from capacitors, inspired by the work from the other scientist Galvani on frog legs. All right, so our next, taking that one step further, is voltage is the electrical pressure that causes electrons to move, because electrons don't like each other, like repels like. Current, electrical current, is the result of electrical pressure. All right, and so when many people first learned this concept, they're actually taught something called Ohm's law. And we'll get to that next. But Ohm's law says voltage is equal to current times resistance. And a lot of new students, they get confused because they're like, okay, well, does that mean that electric current causes voltage? No, it's voltage, electrical pressure, causes electric current. All right, this is not a chicken and egg thing. This is voltage, clearly number one, then current, the flow of electrons, come as a result of the pressure that we call voltage. All right, so if we look at a modern battery, say AAA battery, a AA battery, and you were to take it apart, you could see sort of a slightly more complex version of our two pieces of metal separated by an electrolyte, such as battery acid. Okay, and so if we were, say, had a dead battery that was no longer able to charge its plates relative to each other, then we'd have zero voltage. If you have zero voltage, then you have no electrical pressure, and you're going to have no current, no flow of electrons. Say you have a good battery, though. We have a 12-volt battery. It's got 12 volts of electrical pressure, and you connect it, our negative charge plate to our positive charge plate, one into the battery to the next. then you are going to have electrons flow. All right, so if we have voltage, electrical pressure, then we're going to have electrical current as a result. Okay. All right, so what if we wanted to, say, throttle the amount of electrical current we had? We'd use resistance. Resistance is quite literally the resistance to the flow of electrons. And this is a material property. All right. What does that mean? Well, previously we talked about things like electron affinity. If a substance has, say, more protons than another substance, and an individual element is defined by how many protons are in its atom, if we have a certain amount of electron affinity, say we have more than less, we're going to have, say, more resistivity. All right, so this is a material property that's based on the model of the atom. Okay, then if we were to, say, have a longer piece of wire than a shorter piece of wire, the resistance of the wire would go up, resistance to the flow of electrons. And if we were to, say, increase the width of the wire, that'd be called the gauge of the wire, increase the width, then the area, because we're dealing with a circular cross-section, then the electrical resistance would go down. All right, just like a water going through a tube. It's a big tube. It's going to be easy for water to go through. It's a small tube. It's going to be hard for water to go through. All right, but electrical resistance depends on, one, material property, and then two, the shape of the object the electrons are going through. All right, one last thing. So if resistance is the resistance to the flow of electrons, more resistance means less electric current going through a circuit, which is just a loop connecting two ends of a battery from high voltage to low voltage. Okay, and then we have less resistance would be like opening up having a bigger pipe of water for our water to go through. That'd be like a bigger wire for our electricity to go through. Less resistance means it's easier for our electric current to move. All right, and the final thing is a demo that we're going to see in class that you heat up. If you have ever wondered how a toaster works, well, every time you have electricity going through a wire, heat is generated. And so our toasters are these wonderfully simple devices where we just plug wire into our wall outlets, which provides electrical pressure in the form of voltage. All right, that's it for now. See you guys in class.